So let's start our today's topic, which is sorting algorithm. So before getting deep dive into sorting algorithms, let's first understand the why, what, and how. It's always the best to understand why, what, and how of every data structure or algorithm before diving deep into that. So uh, the why is basically why we are using that algorithm or why we are using that data structure. What is, as the name suggests, what is that algorithm actually, and how is the that algorithm, how is that implemented in the code in your favorite language, right? So let's start with the why. So for this, let's take a real world example. You went to a medical shop and you need a paracetamol. You told them, and suppose they haven't sorted their medicine, it's in the random order, right? So what will happen? It will take more time to search that paracetamol. In the worst case, in the worst case, they have to find each and every go through each and every medicine to get that paracetamol, right? So instead, if they have sorted their medicine in some order, let's say on the basis of symptom or disease kind of thing, like fever, cold, cough, in that case, it would have been much easier and faster, right? So from this example also, we can get to know if things are sorted, we can actually search anything easily and faster, right? So how is it even relevant to our data structure and algorithm? So similar to there where we was finding medicine in the shop, here if we want to find an element in an array and the array is not sorted, then the worst time complexity could be it could be found in the last index, and that would be O of n. Instead, if we have a sorted array, we could have applied a binary search algorithm upon that, and we could have found that element in n log n, sorry, log n, time complexity. And yeah, obviously n log n would be to sort the array. Now, uh, now from that we got to know if the elements are sorted, we can actually reduce the time complexity and it would be easier and faster. So that's what we do in data structures and algorithm, right? So we have now understood why we are using sorting, right? To reduce the time complexity and many more other application it has where it reduces the time complexity. Now coming to the what is sorting? So sorting is basically when you want to arrange your data or the sequence of element in any kind of order, let's say ascending, descending, or any other logic. For those any other logics, we have our custom comparator where we can um, give our own logic, and based on that logic we can sort, right? So that is sorting whenever we want our data to be in a structured form. So now coming to the how. So for understanding how, uh, let's take an example of any popular sorting algorithms. We have selection sort, merge sort, heap sort, and yada yada. So yeah, let's go to one of my favorite sorting algorithm, which is merge sort. So merge sort, basically it follows a recursive paradigm, and in that it follows divide and conquer strategy. So what is divide and conquer strategy? The divide and conquer strategy says that if we are given a bigger problem, we have to divide that into a smaller subproblem, right? For those smaller subproblem, we have to find a solution to that, and we have to combine all those smaller subproblem solution. That would be a solution to the bigger problem, right? So that is what divide and conquer algorithm is. In merge sort, we have this array, for example. So this is now a bigger problem. And in merge sort, actually, what is a smaller problem? We need to solve the smaller problem and then combine, right? So in merge sort, the smaller problem is when we have single element like these. We will keep on dividing the arrays from the midpoint into half, from the midpoints, half and half, and we will keep on dividing until it is uh, single element. Then after that is done, we have now to will now combine it using swapping and all, merging. So that is how merge sort is done. And we have many application of merge sort, like inversion count, which can be easily done through merge sort. So yeah, that's it for today. And yeah, thank you.